Hello everybody, in this video we're going to start to learn the residual analysis in the chapter 16, the nonlinear regression model. So before we start to look at the residual analysis, I want to explain a little bit why we need a residual analysis. So the residual analysis has another name called the diagnostics. So the reason we need a residual analysis and the diagnostic is because the linear regression model we learned from previous chapter actually have a very strong assumptions imposed on the model. So basically, it's like your econ classes. You learn the supply and demand. So it always look like a straight curve. So the reason it was a straight curve, and also we only look at how the changes of the price affecting the quantity. So the reason we have that able to do that analysis is because we are assuming other item are not changed. So they're like a ceteris paribus. So that was a strong assumption imposed on economic model. So here we are learning the statistic model, very similar as an economic model. So it also has to be impose some kind of assumptions. So basically it means if we got the data and then if we can use some kind of statistic method to test out that we found that the assumption we impose on model doesn't hold, that actually means the model we're using has a problem. So the model we're using has a problem. So what should we do it? So that's what we're going to look at in chapter 16. So if we're going to see the nonlinear relationship, especially we saw the curvature, and we should consider using other form of the linear regression model. So first of all, let's look at what are the assumptions are imposed on our regression model. And so in order to understand the number of the assumption imposed on the regression model, so let's look at a very important definition because most of the assumptions imposed on the regression model are imposed on the special statistics. So this statistic is called a residual. So what is residual? So residual is the difference between the observed value of the dependent variable and the value predicted by using the estimated regression equation. So that is called residual. So actually, the residual is the best estimate for the error term in the regression model, right? Did you remember this notation, epsilon? So that's our error term. So if you think about if the model works really good, and so the estimate value should equal to the real value, right? However, that's not the case. In the statistical world, you won't be able to find the perfect model to modeling your observation. What we can control is control that residual. So we try our best to make sure the predicted value is look as close as we can as our observation. So our assumption, except the first one, are imposed on the residual, this error term. So let's look at our 5 assumptions. So generally speaking, we have 5 assumptions imposed on the regression model. It depends on the textbook. Sometimes they say 4 because they combine 3 and 4 as 1. So in this class, we emphasize 5 because we actually will notice that the different assumption will use a sort of different chart to diagnose them. So the first assumption is the linear relationship. So we're assuming x or y has a linear relationship. And the second is called the variance of the residual, and we should use the sigma squared to denote it. It's the same for all values of the independent variable. So basically, we think the residual shouldn't be affected by your x variables. And number 3, the error term is a random variable with a mean of 0. So we're thinking this residual or error is a random variable. And so if we try to add all of the residual together, divide by the number of observation, should equal to 0. So that's basically what this assumption means. Number 4, the residual is a normally distributed random variable. And so if we try to draw the distribution for this residual, we should see a bell curve. So that should be a normal distribution. Number 5, we're assuming each residual are independent from each other. So basically, the first residual shouldn't affect the second residual, and the second residual shouldn't affect the third residual, etc. And so the last one I mentioned here is the finding outliers. So this is not part of the assumption, but sometimes kind of important if you will be able to use the technique to identify the outlier in your data set. So before we move on to look at how we're going to examine these 5 assumptions, and I want to mention about the importance of learning this chapter. So we call it diagnostics, so which might remind you some medical term, diagnostics. So when you are sick, you're going to go to the hospital to do the diagnostic, right? So or even at home using some math tool, you can diagnose yourself. So for example, you got fever. So how do you know the fever? How do you know you got fever? So first of all, you have to know, or you have to remember, what is the threshold to identify you have a fever. So which means that threshold temperature you have to know, which means you have to remember that threshold. So basically after this chapter and after this 2 slides later, I'm going to show you the healthy patterns. So those are the pattern, the characteristics of those patterns you have to remember it, just like you remember the threshold to help you identify whether you have have a fever or not. So you have to remember what are the healthy patterns you are looking for in order to know whether the assumption is not violated or not. So what is the second requirement? Second requirement, think about, in order to know if you are having fever or not, you're gonna need a thermometer, right? You need to use thermometer to test now. You're not to go to draw your blood to figure out if you have the fever. The right method you're using is using thermometer. So that's the second requirement for learning this part, is remembering which chart you should use to test which assumption. So like I said, you cannot use the chart. You're supposed to test the second assumption to test the first assumption. So that will be wrong. And then the third requirement is you have to remember these 5 assumptions. And why? Because just like you have to know what's the problem you have when you feel sick. So you have to remember, oh, I might have a high fever, right? So then therefore, you have to remember what you're testing. So these 5 assumptions you have to remember. So 3 things, 5 assumptions, what are they? Second, what are the charts you should use to test which assumption? Number 3, what is the healthy pattern you're looking for so that you will be able to make the judgment whether assumption is valid or not. Okay, so next, let's look at what kind of tool you should use to test each assumption. So the assumption 1 is our linear relationship. So in order to test out this assumption, you should use a scatter plot, x versus y. So this is the chart we learned from chapter 2 when we are learning how to use graphical method to show the relationship between 2 variables. So that is the one you should use to testing if linear relationship holds or not. And the second assumption, the variance of the residual is the same for all values of the independent variable. So the chart we're using is called a residual plot. But here, I want you to remind yourself that both assumption 2 and assumption 3, you are using residual plot. But those 2 charts you have to develop by yourself. Don't using direct develop the chart from the Excel. So that's why pay attention on your horizontal and vertical axis. So vertical axis will be the residual, and horizontal axis will be the estimated or predicted value, y value. So you have to develop by yourself. So when you watch the computer skill 6 video, and you will notice that this residual plot is not directly coming from your computer. You actually have to generate by yourself. So assumption 2 and 3, we are using the same chart. However, we are looking for different characteristic of that chart in order to understand whether the residual, so whether the residual's variance is independent from all value of x, or whether the residual is a random variable with a mean of 0. So the same chart tests the 2 and 3, but we are looking for a different pattern. So let's look at the next one, the number 4 assumption. We're assuming the residual is normally distributed. So therefore, we're looking for the normal probability plot. So normal probability plot. And The next one is the residual versus the order of the observation plot. And so we're using this plot to examine our assumption 5. So the value of the residual are independent. And so this one is using the residual versus the order of the observation plot. So similar as a residual plot, we need to create this plot by ourselves. Computer won't be able to generate it for us. So the vertical axis is the residual and the horizontal axis is the order of the observation. So the last one I'm showing you here is used to finding outliers. So this is not part of assumptions. So this is literally just help us to find outliers. So this is not part of assumptions. So in order to find outliers, we're going to create the standardized residual versus the estimated y-value plot. So now that is the plot we're looking for. So like I said, after we look at this five plot, we're going to look at the healthy pattern. So now we learn 2 out of 3 required information you have to remember. So first, what are assumptions? Second, what are the method you should use, or what kind of chart you should use to test it out assumption. So number 3 will be what are the healthy patterns, so that can guide you to make a decision whether the assumption is valid or not. So first, let's look at our linear relationship. So like I said, for the linear relationship, we are looking for the scatter is not scattered too far away from your trend line. So when we look at the scatter plot, so you can see in this case on the bottom, it's indicating a healthy plot. That means this plot indicated first assumption is not violated. So why? You're going to check in these 2 characteristics for this scatter plot. So first of all, the vertical axis is your y variable and horizontal axis is your x variable. So when you look at this scatter plot, you need to check first no curvature. Obviously, you can see the scatter showing you a straight line, right? So no curvature. And the second you're looking at is can you find any dot that is really far away from your trend line? So that's the second thing you need to check. The third thing you need to check is the scatter should be evenly distributed around your trend line. So if you look at this case, so all your scatter is scattered very closely and around your trend line. So therefore, if you check this all 3 patterns, you not identify they all satisfied. So then your conclusion will be, okay, so this assumption is not being violated because no curvature, the scatter are not scattered too far away from your fit line, and also your scatter are evenly distributing around the trend line. So this is the first assumption. And so we look at the second assumption. So the second assumption, we are using the residual plot. So if you pay attention on this plot, so the vertical axis is the residual, and the horizontal axis is we call the predicted value. In this case, they're predicting the alcohol consumption. So this is the predicted y value. So in order to know the residual plot, in order to know the second assumption, the residual or the variance of the residual is the same for all values of the independent variable. So first of all, you're going to create this chart on Excel. After watching the lecture part, make sure you're going to watch the computer skills 6, because that actually going to teach you how to generate this chart. And so after you create it, so what you're looking for is the horizontal band. So how do you know this is the horizontal band? So first find the edge of your scatter plot. So this gives you a shape, right? So this is going to give you a shape. So if you look at this chart, so if you draw the shape of your scatters, and you actually notice that, okay, wait a second, this is horizontal band, right? So the pattern you're looking for is a horizontal band, So in some real world situation, if you saw your residual plot is like that. So let's see, this is the residual, and this is your y, estimated y value, so this is y hat. So now if this is the case, you saw the edge of your scatter, and then you try to find edge of scatter. You notice that this obviously is not horizontal band. Instead, it's a wedge shape or cone shaped. So in this situation, so we indicate that our second assumption is violated. So this is how you make the decision if your second assumption is valid or not. So now look at third assumption. We are using the exact same chart, residual plot. And so in this situation, in this assumption, like I said, we are using the same chart, but we're looking for different kind of patterns. So what we are looking for here is the scatter create a shape that is symmetric, and the centered at 0 horizontal line. So if you look at this chart, we said this is not violating my assumption. If I can find an edge of my scatter, so then you will be able to picture a shape, right? The shape. So this is like a horizontal band because we're using the same chart as we used in the previous one. So the key here is we're going to look at this horizontal band, whether this is symmetric and whether the center is at this 0 horizontal line. So if you look at this diagram, you notice that, yes, this is a symmetric. It's upper and the lower of this horizontal line. They look exactly the same and they're symmetric. So therefore, the third assumption is not violated. So in order to answer this question properly, as I said, you have to remember those healthy patterns you're looking for. So this is assumption 3. So for assumption 4, so the residual is normally distributed in a random variable. So later you watch the computer skill 6, you will notice that Excel will generate this chart for us, this diagram for us. So what are the healthy patterns we're looking for? So we are looking for if those dots, so they will be able to follow in a straight line. So if you see the diagram showing you, the plot showing you, the dot is connected, is approximately like a straight line, then we know assumption 4 is not violated. So for assumption 5, so the residual are independent. So we're using this chart. It has to be created by ourselves. Like I said, chapter computer skills 6, I actually showing you how to get this chart, before after you got this chart, and what you are looking for is you are looking for no big U shape. So we are not looking for U shape, we're actually looking for no big U shape. So if you look at this diagram, and you can try to just connect the dots based on their orders. So pay attention, the horizontal axis is a residual and the vertical axis is the order. So what you need to do is, the nice thing for the Excel is Excel can generate scatter plot with the line connect the dot based on the orders. So now you are using the, make sure you watch computer skill 6. So they're actually going to able to generate the scatter plot with the straight line connected based on the order. So if you look at this case, oops, I just tried to connect the dot to show you. So hopefully I'm not doing too bad job. Oh, sorry. So down here, go up. Go 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 down here, go up. So you can see my dot always up and down, up and down. So it doesn't mean the previous residual is larger, means the next one going to be larger or smaller. So they don't have that kind of connection. The reason we notice that is there is no big U shape. And so some students can say, what do we mean by big U shape? So after you connect dot, if you can see like a big U shape like that, obviously it's not because this dot come pop the back up. So this is not big U shape. So this is the healthy plot. Therefore, you won't be able to see the big U shape. So after this assumption, and I will show you several examples that are indicating each assumption is violated. And so the last example I show you, you will notice that, oh, wait a second, you can see the big U shape. So let's look at our unhealthy plot. And so how do you know those are the unhealthy plot? That's why you're going to remember the healthy characteristic you're looking for. So this is the 3 scatter plot, X versus Y scatter plot. Remember, we're using that to test out whether assumption 1 linear relationship is violated or not. So this is called unhealthy plot, means all 3 violating my assumption 1. The question is why? So to answer this question, why, you need to go back to look at what are the healthy pattern you are looking for. No curvature, not scattered too far away from the straight line, the scatter are evenly distributed around the trend line. So those are 3 characteristics we're looking for. So now look at this unhealthy plot. So first of all, look at this one. Why it's violating assumption 1? Yes, look, you have one dot that is really far away from your trend line, right? That's one thing. The second is you also can see the dot is not evenly distributed around your trend line. And so majority of the dot is below your trend line and only have a few above the trend line. So in this diagram, violating 2 out of 3 patterns, 2 out of 3 patterns. So now look at this diagram. Why this is violating my assumption 1? Yes, first of all, you can see a little bit curvature, see it? And the second is the scatter is not evenly distributed around your trend line. the reason is because you only have 3 dots above the trend line, and the majority of the dot is under the trend line. So that means this is not evenly distributed around the trend line. So 2 out of 3 reasons are validated. Therefore, this assumption is validated. And so this one is even more obvious. You can directly see this curvature, right? Curvature. So this was just based on this assumption. You see the curvature, you know the first assumption linear relationship is violated. So you can see, in order to properly answer this question in your homework and exams, you first need to know what is the right chart you should use to test each assumption. Second, you have to remember those healthy patterns. So now look at the second assumption. So we're assuming the residual variance is independent from your y variable. So for this plot, this assumption too, we're using the residual. You can see both chart, the vertical axis is residual and versus the estimated or predicted y value. So remember the pattern we're looking for, right? So the pattern we are looking for, look at assumption 2, is our horizontal band. So horizontal band, so now we go back to see, can we see the horizontal band? So first we draw the edge or find the boundary of your scatters. Obviously, this is definitely is not horizontal band. So this is like a two band that curved. So this is not horizontal band. Therefore, it is violating assumption 2. So look at this one. So this one, you notice that it is a band, but it's not horizontal. Therefore, it is violating assumption 2 as well, assumption 2. So this is how we use the residual plot to test assumption 2. So look at assumption 3. So assumption 3, let's look at assumption first. So the residual is a random variable with the mean 0. To test out this assumption, so the scatter create a shape that is symmetric and center at the 0 horizontal line. So let's look at the example we're going to see here. So we call it unhealthy plot because this is our violating my assumption 3. So the key here is, can we find that symmetric shape? So let's draw the edge of this curve. So you're noticing that this is not symmetric around this 0 line. So you do have dot above 0 horizontal line and then below. But you can see we have this actual part make our chart asymmetric. So they are not symmetric. Therefore, we have this diagram indicating this model violating my assumption 3. So now we look at the assumption 4. So assumption 4, we're assuming the residual is normally distributed random variable. So if we are going to using the normal probability plot, and this plot will be generated from Excel, and we're looking for is the point should fall approximately along a straight line. So that's a healthy pattern we're used to do that judgment. So now if you look at assumption 4, those are unhealthy plot. So first of all, look at this one. Seems like everything are straight line except that one. So therefore, assumption 4 is violated. Not all the scatter are approximately a straight line. So look at these two. It's even more obvious, and you can see the beginning and the end, beginning and end. So those are creating a S shape instead of a straight line. So therefore, your assumption 4 are violated based on this all 4 chart. So assumption 5, look at assumption 5, we are looking for the residual versus the order observation plot. We're going to create it by ourselves. So what we're looking for here is no big U shape. And so look at unhealthy plot here. So unhealthy plot, so all 2 indicating unhealthy plot. Look, is that the big U shape? So you did see a big U shape. Also similarly like that one, 1, 2, and 3. So there are 3 big U shape. This one had 1 big U shape. So